Here is a problem, gate problem 2019 related to electromagnetic theory. A circular loop made of a thin wire has radius 2 cm and resistance of 2 ohm. It is placed perpendicular to the magnetic field of magnitude B naught equal to 0.01 Tesla, and at time t equal to 0 the field starts decaying B naught e power minus t by t naught. The total charge that passes through the cross section of the wire during the decay is Q. The value of Q in microcoulomb is asked. So here a perpendicular magnetic field, changing magnetic field passing through the coil results in the EMF induced in the coil. Due to this EMF induced, a current flows through the coil. So EMF induced is given as minus d pi by dt. So here d pi by dt, pi is the flux linked with the coil. So what is the relation between flux and the magnetic field? So it can be written as B into area of the coil. So substituting the value for B, differentiating that with respect to time. B naught e power of minus t by t naught. Here t naught is given as 1. And substituting the value for A as pi r square, where r is the radius of the coil. Differentiating this term with respect to time, we are having e power minus t. So differentiating, we will be getting e power minus t by minus. So minus minus, we are already having minus, so we get plus. So the result will be, that is the induced EMF B naught e power of minus t. Substituting value for 1 for t naught, we get B naught e power minus t pi r square. This is the induced EMF. So from the EMF induced, we can calculate the current I. EMF induced by the resistance of the coil, that is given as 2 ohm. So I is equal to B naught e power of minus t pi r square by r. What we want to calculate is the Q, the charge. We know the relation between Q and I, that is the rate of change of charge with respect to time is the current. So we can write the Q as integration of I with respect to time, and the limit is from 0 to infinity. So Q is equal to, and we know the expression for I, B naught e power minus t pi r square by r. E power minus t pi r square by r. Integrating with respect to dt, the limit is from 0 to infinity. So integration of my e power minus t gives minus e power minus t. Substituting the value is 0 to infinity, and we get 1. Lower limit e power is lower, substituting the lower limit 0, e power 0 is 1. And we are having the other constants B naught pi r square by r. So substituting the value of B naught as 0.01 and pi as 3.14 and r square as, or the radius of the coil as 2 centimeter, change to 2 meter by adding 10 power minus 2 whole square divided by resistance of the coil is 2. So 2 and here 2 cancel, we get 0.01 into 3.14 into 2 into 10 power minus 4. So the answer is 3.14 into 2 we get 6.28, and the power 10 power minus 6 microcoulomb. This is the charge crossing the crossing the wire during the decay of the magnetic field.